Hello, everyone. Welcome to our talk on Global Table Extractor, which is our deep learning framework for joint table identification and cell structure recognition using visual context. This is joint work between me, Nancy Wong, and several of our colleagues at IBM Research. To start, I want to lay out the problem at a high level. The input is a document content in its native format, such as PDF, image, or even Office document. And the goal is to extract the table structure. And this includes its table border for each of the tables, partitioning the table contents into cells, and also both the vertical and horizontal alignment of cells. Once all these three pieces of information are correctly extracted, you can express this table in a structured format, such as HTML or XML. This sounds like a very straightforward problem, but it's hugely challenging, partly because of the huge variety in tables. And this includes the style. For example, with tables can have graphical lines or without, and sometimes these can be misleading. And also in structure, where you can have multi-row, multi-column nested headers, and sometimes even tables within other tables. To solve this, tackle this problem, we are leveraging object detection improvements in the natural image space with deep learning networks in order to detect these tables and cells. In essence, we're representing tables and cells as objects on a page, similar to how in other works where you're looking at cars and humans on natural images. But to be able to train these networks, first we need ample amount of data. And unfortunately, there wasn't really much out there when we first started. So we actually developed a method to automatically match between structured and unstructured forms of data to be able to label the unstructured type like PDF. So we enhanced the scientific data set that's already pre-existing called PublabNet with cell bounding boxes through this automatic text matching method. And this results in more than 500,000 tables from scientific sources like PubMed. And you can go ahead and download that in the link provided. In addition, we created a completely new data set called FinTabNet that's automatically compiled from annual financial reports of S&P 500 companies. This results in more than 100,000 tables, and financial tables are arguably more complex and certainly very different from scientific documents. And you can also explore and download this at the link provided. So now that we have the data set, we look back at the model. For us, we realized that there are several key insights that can help improve a object detector framework specialized for table and cell detection. The three key insights are that tables and cells have very different size and aspect ratios, which is very different from regular object detection classes. And cells are always inside tables, and tables are always contain cells. It's very useful. And finally, object detectors can work well locally, but sometimes neglect the overall style of tables. So we exploited all these insights in our GTE framework, which resulted in state-of-the-art results in both ICDR 2013 and 2019. And you can look at more details on the results in our paper, as well as the method. Here, I'll give a very high-level overview of the most interesting parts of our system. For GTE table, we have this extra penalty loss that is given, that is given for very unrealistic tables, in the sense that if it doesn't have many cells detected inside in the table, or have a lot that's detected right outside of it. And as you'll notice, we also have two different object detectors for tables and cells, and this helps with the kinds of anchor boxes we're able to make, since they have very different aspect ratios and sizes. For GTE cell, our key innovation here is to have a hierarchical network that first looks at what kind of style it is. In our case, we focus on graphical lines. And and sends it to different networks that are specialized for it. And you can see our ablation studies to see how much improvement these innovations made in our overall results. Thank you very much for listening. And I'm happy to take any questions during the question and answer period. And please take a look at our paper and look at more details in there. Thank you very much.